So another example from chapter 6.4 asks us to write an equation for these graphs. Okay, so we know that the general formula for a logarithmic graph with transformations is going to be, let's say, h of x equals plus or minus a times log base b, whatever base we're given, of x minus h and then plus k, where h is going to be our horizontal translation, which is given to us by the vertical asymptote, and then we're going to solve for k. And then a is going to be given to us by changing the way it's written up here. We have that log base b of x is equal to log base 10 of x over log base 10 of b. And then finally, the plus or minus at this end here is going to be given by vertical reflections in the graph. So we start with part A, and it gives us this f of x here. We know that the vertical asymptote is going to be here at x equals 3. And then we can pick a clean point from the graph given, right here. And this is going to be 4, negative 2. And then we can use this to write our equation. So we have that f of x equals, and in this case is going to be a plus because there's no other vertical reflections. It looks the same as our parent function, except it's just translated down to where it is right now. So we have log base 10 of x minus 3 because of our x equals 3 vertical asymptote. And then all of this over log base 10 of 4, because if log 4 of x was our parent function, then we can just use this up here to rewrite the equation. And then we have our plus k. So now we can plug in what we actually know. We have, since we have this point 4, negative 2, we know that f of 4 equals negative 2. So then we have a negative 2 equals log base 10 of 4 minus 3 over log base 10 of 4 plus k. And from here we can just solve from k. So since 4 minus 3 is 1, log of any base of 1 is going to give us 0. So 0 divided by whatever this is down here is still just going to be 0. So k is negative 2. And then our equation f of x equals log base 10 of x minus 3 over log base 10 of 4 minus 2 is our equation. And furthermore, we can just simplify. We know that log base 10 of 4, we plug this into a calculator, this is going to give us 0.602. So our final f of x is going to be log of x minus 3, the base 10 is implied, and then over 0.602 minus 2. So that's our f of x. And then part B gives us this g of x, and it's going to be the same idea. So we have our vertical asymptote this time is at x equals negative 2. So our h is going to be 2. We also know that our parent function is shaped like this. So if we were to flip it horizontally, so our equation is going to look like such. We have g of x equals negative log base 10 of, we have negative x plus 2 over log base 10 of 2. And then we have our plus k. So again, just like the first problem, what we can do is pick a clean point. We can find one here at negative 3, negative 1. And then we can plug this in and solve for k. So this point means that f of negative 3 equals negative 1, and we can just plug that in. So negative 1 equals negative log base 10 of negative 3 plus 2, and I close that, all over log 10 base 2, and then plus k. So negative 3 plus 2 is going to give us negative 1, then negative 1 is positive 1, so log of 1 again is 0, so this whole term becomes 0, then we have that k equals negative 1. And then we have that log base 10 of 2. If we plug this into the calculator, it's going to give us about 0.3010. So our g of x is going to be given to us by negative log base 10 of negative x plus 2 over 0.3010 minus 1.